Hello everyone, welcome back. It's been a while, but let's do the equations of motion. So, under the equations of motion, we have four equations of motion. So, the first one said Vf, as for final velocity, is equals to the V initial, which is the initial velocity, plus the acceleration multiplied by time. So the second one is a final velocity squared is equal to the initial velocity squared plus 2a, the change in x. The x is for distance or the displacement sometimes. And the third one, the change in x, which is our distance or the displacement, is equals to the initial velocity multiplied by the change in time, plus 1/2 acceleration multiplied by the change in time squared. The last one, the change in x is equals to the final velocity plus the initial velocity divided by 2 multiplied by the time. So velocity, as for v, let's say vf, this one, the SI unit, it says meters per second. As for v initial, as long as it's a velocity, the SI unit is meters per second. So for acceleration, the SI unit for acceleration is meters per second squared. So make sure you differentiate it when you read the statement or when you want to answer a question. So we have time, so we always measure time in seconds. If time is given in minutes, you make sure that you convert it to seconds. If it's given in hours, you make sure you convert it to seconds. So the change in x, like I said, is a displacement or is the distance. So we measure our distance in meters. So if it's given in kilometers, you make sure that you convert it to meters. If it's kilometers, they convert it to meters. So for meters per second, sometimes they give you in kilometers per an hour, for example, kilometers per an hour. You make sure that you convert the kilometers per hour to meters per second by, for example, let's say 20 kilometers per an hour. Kilometers per an hour. So this one you just divide by 3.6. So this one now is going to take you to meters per second, just like that. So for seconds, if it's given, for example, 2 minutes, you make sure that you multiply by 60 seconds. Then it will give you in seconds. If it's hours, for example, you multiply by 60 minutes, multiply by 60 seconds. So it will give you in seconds, just like that. This one, if it's given in kilometers, you just multiply by 1000. So one kilometer is equal to 1000 meters. So this one, it will give you in meters, just like that. So let's move on and see how we answer the question. A train slows down from 40 meters per second to 10 meters per second in 60 seconds. How far does it travel in that time? So they said it slows down from 40 to 10. So from, this is what we call the initial. From is initially, to is final. So remember, we said velocity is meters per second. It's in meters per second. Now they said the train slows down from 40 meters per second. That is the velocity. But from, it means that it's the initial velocity. So let's say we write down the data. They said initially they said is 40 meters per second. So the train slows down from 40 to 10 meters per second. So that 2, we call it the final velocity, which is 10 meters per second. So they said in 60 seconds. So we're given time as 60 seconds. So let's say our time is 60 seconds. So the question said, how far, that means that is the distance, how far does it travel in that time? So how far does it travel in that time? We don't know. So now, according to the data, which formula are we going to use? So let's say we go back to our equations now. What do we have? We have the initial velocity, we have the final velocity, and we have time, but we are looking for the distance. That means we want the formula with initial velocity, final velocity, time, and the distance, which is our unknown. So let's check now. The first one, it doesn't have the distance. That means we cancel it. We don't want that one. The second one, it has the distance, but it doesn't have time, and we do not know the acceleration. So okay, we cancel that one. The third one, it has the distance, it has the the initial velocity, but it doesn't have the final velocity, and we do not know the acceleration. Then we cancel that one. That means we're going to use number 4. So number 4 says the change in x is equals to v final plus the v initial over 2 multiplied by time. So when we check, we have the initial velocity, we have the final velocity, we have time. We are looking for the distance. So now, what is our final velocity? Already we have it in the data. Vf is 10, so just write 10 plus the v initially 40. So we write 40 divided by 2. Then our time is, it said it's 60 seconds. Just like that. So now 10 plus 40, that is 50 divided by 2 multiplied by 60. So 50 divided by 2 is 25. 25 times 60, that is 1500. So that is 1500 meters. So that means now the answer is 1500 from the question. Now let's move to the following question. The question says, what acceleration will be needed by a car speeding up from 10 meters per second to 15 meters per second? So you can pause the video and try the question out. So let's say the data. The question said, what acceleration? A. What acceleration? That means the question is looking for the acceleration. Now, they said, what acceleration will be needed by a car speeding up from initially 10 meters per second to, that is finally 50 meters per second. So it's speeding up from 10 meters per second to 15 meters per second in 80 meters. So 80 meters, that is our change in x. Remember, I said we measure our distance in meters. So it is given in meters, which is 80 meters. Now, the question said, what acceleration? So let's say we go back to our equations now. So according to the data, we are looking for the acceleration. But what are we given? The initial velocity. So initial velocity were given, final velocity were given, but we don't have time. That means we cancel this one. Since this one it has time, so we cancel this one. Now the second one, the final velocity is there, initial velocity is there, acceleration, we are looking for the acceleration. The distance, that means the distance is given as 80. That means, let's say now we're going to use this one. So V final squared plus is equals to V initial squared plus 2a the change in x. This is the formula now that we're going to use. So what is the final velocity? The final velocity is given as 15. So it's 15 squared from the formula is equals to initial velocity is 10. 10 squared plus 2a. We're looking for the acceleration. The question said what acceleration? So change in x is given as 8. So we have 8 here. Now 15 squared, that is 225. So equals to 10 squared, that is 100, plus 2 times 80, that is 160, 160a. So now we take 100 to the other side. That means this side we're going to have 160a is equals to 125 minus 225 minus 100, going to be 125. So now we're looking for the acceleration. We divide by the coefficient of a, the coefficient of a. So acceleration is equals to 125 divided by 160. That is 0.78 meters per second squared. That is acceleration. The SI unit, remember, meters per second squared. For velocity, it's just meters per second. So this one is acceleration, meters per second squared. So now let's move to the next question. Now the question says, if an object dropped from rest and falls 16 meters before hitting the floor, how long does it fall for? So they said you take the acceleration due to gravity to be 10 meters per second squared. Since the object is falling, that means it's in free fall. So the acceleration, they said you take it as 10 meters per second squared. So now let's break it down. Data. They said an object is dropped from rest, that is initial. V initial is equals to, they said rest. That means the initial velocity is 0 meters per second. Then, and if they said what? An object is dropped from rest and falls 16 meters. So this one is going down now. That means let's call it the change in y. It's vertically y, horizontally x. So this one is falling. That means it's vertical. So the change in y is equal to 16 meters. Then they said before hitting the floor, how long does it fall for? So how long, that is time. We don't know the time. Then they said you take the acceleration as what? As 10 meters per second squared. That's what they told us. So now, according to the data, which formula we're going to use? So we go back to our formula sheet. So the formula sheet, it will be given to you in an exam. So we have the initial velocity. So for this one, we are not given the final velocity and we are not looking for the final velocity. That means we cancel this one. The second one still has final velocity. That means we cancel it. The third one, and here now we're going to use y. Find distance is given as 60. V initially is 0. The question said how long, that is time, and the acceleration is given. That means we're going to use this one now. Equation number 3. So equation number 3 says change in x is equals to v initially change in time plus 1/2 a change in t squared. So, but according to the statement, the object is falling. That means now instead of x, let's say we use y. Since it's vertical, we use y. So now, what is the distance? The falling distance is 16. So we have 16 is equals to v initially. They said initial velocity is 0. The change in time, we're looking for time here. The acceleration 10, just write 10. Then the change in time squared. We don't know the time. So now 16 is equals to 0 times change in t, anything multiplied by 0, that is 0, plus 10 multiplied by half, that is 10 divided by 2, which is 5. Change in time squared. So now let's say this one is 16 is equals to 5, the change in t squared. This plus 0, just that. So now we divide by the coefficient of time, and then the change in time is equals to 16 divided by 5, that is 3,2. So, oh, sorry, this one is squared. So, since we are looking for the time and not the time squared, so we just put the square root, then the square root of t squared, that is the change in t, is equals to the square root of 3.2, that is 1,79 seconds. So this is the time the ball or the object is falling for that distance, which is 16 meters. When you take the acceleration due to gravity as 10 meters per second squared. So thank you, and please don't forget to subscribe.